this is the dot product section, which is, hello Scout, which is simply how you multiply two vectors. So the dot product of two vectors is a real number, scalar, and sometimes referred to as the scalar product. So if, in other words, you have this one vector with a horizontal and vertical component, a second vector, then their dot product would simply be found by multiplying the scalars and then putting plus in between, so adding. So let's see if we can do this. So for example, if I have vector v, which is 2i minus 3j, and I have vector w, which is 5i plus 3j, and I'm asked to find the dot product v dot w. So all I do is I multiply the i's, so in other words the horizontal component, and then add to the negative the vertical component. So as you can see, I get 10 minus 9, or 1. You can also do the, so technically, I get tired of drawing the arrows, but the dot product of the same vector. So that would simply be the I twice, 2 times 2, and then plus negative 3 times negative 3, which would be 4 plus 9, which gives me 13. If you are asked to find the magnitude, if you remember, that was square root, and then my horizontal component squared, my vertical component squared. So that gives me 4 plus 9, which do you think it is a coinky dink? Or hi. So that's kind of nice to know. All right, so there's that. If I also can see that these are nice little properties, just my algebra properties, commutative property, distributive property, and as you just saw here, the vector times vector dot, so in other words the dot product of the vector, I get the magnitude, and then of course if I have a zero vector times another vector, I get 0. Angle between vectors, this is actually pretty useful for a lot of applications. So if I have these two non-zero vectors and this particular angle theta, and theta lies between 0 and pi, so between my u and v is determined by this formula. So let's see an example of one of these. So let's say I want to find the angle between, I have vector u, and that's going to 4i minus 3j, and vector v, 2j plus 5j, no, I plus 5j. And so again, my formula, since you're just learning it, I would go ahead and just rewrite the formula down so we can start plugging everything in. The numerator was the dot product between these two, and then the denominator is the magnitude multiplied. All right, so up top, as you can see, my dot product is going to be 4 times 2 plus negative 3 times 5, and then the bottom, square root 4 squared plus negative 3 squared, and then square root, these are being multiplied, the two going to be multiplied, 2 squared plus 5 squared. So up top I have 4 times 2 is 8 minus 15 all over the square root of 16 plus 9, so the square root of 25, and then 25 plus 4 square root of 29. So certainly up top you can see that I'm going to get 8 minus 15, so negative 7. 5 square roots of 29. And from here, remember all of this is cosine of theta equals this, so I want to solve it for my angle. So how you do that? Inverse. Good job. And so you throw that in your calculator and you should get something like 105 degrees. All right, so again, you're going to see this is a very useful formula to find angle between vectors when we get into applications.